Hey, and then we are started. It's 2 o'clock, so let's start this webinar. We can wait a little bit, have a slow start as people are joining in. We will see. Oh yes, we can see some people coming. That's good. That's good. I'm happy. This is kind of a new area for me. As you know, I'm more famous from the IBM side of things, but nowadays with my company built on power, I focus on everything on power, right? And Oracle is a really interesting solution that runs so well on power, and I want as many as possible to hear about it. I think we should start. I mean, it's supposed to be a relaxed webinar. It will be PowerPoints, but I also want people to join in. So it should maybe be a Zoom meeting instead of webinar. Right now, everybody is on mute, but we can, if someone wants to reach out, you can ask questions in the Q&A or chat window, or raise your hand, and I will keep an eye open for it. This is recorded, and we will see later what we do with it. Right? It maybe depends on what we discuss and what we can do and make public or not. We will at least send this out as a minimum to the participants that is already in here. Okay, once again, welcome everyone. My name is Torbjörn Appel, and I am the guy behind Built on Power. That's my company, and I am the CEO, but also self-employed, so I am everything else as well in this company. I'm focused on power systems and solutions around power, especially since a couple of years. ISVs, applications that runs on power. I'm a champion since IBM champion since 2016, and I've been working with the platform since 1997 actually. It was called AS400 back then. Together with me, I have François Martin from IBM, and also a fellow champion from Tietoevry, Tommi. Hi guys, and welcome.
Thank you, Torbjörn.
François,
Hello.
perhaps you could, a short introduction, François, about your role, which I think is very much of interest for the audience today.
Yes, sure, Torbjörn. So yes, my name is François Martin. I'm from IBM. So today I'm doing competitive sales, but I'm also involved in this power system technology for a very long time. I think it's now 22 or 23 years. When at that time it was called RIX 6000. And from the early beginning, I was also involved in Oracle software running on this platform at the time of Oracle database version 7. I've been doing many different kind of technical activities, from customer benchmarks to writing courses, building demos, writing papers, and even last year participating to a red book about Oracle on Power. So yeah, a lot of technical background about this technology, but also about other technologies, and especially Exadata, Spark storage machines, also about Intel. So I'm able to help customers in their decision, in their strategy for choosing the right infrastructure to run these mission critical workloads, whatever it's Oracle database or Oracle applications.
Hey, I'm very happy to have you in this webinar, and I guess you know Tommi since before better than me. Perhaps Tommi, please, in short introduction about yourself.
So, yeah, my name is Tommi Sihvo. I'm working in Tietoevry and have been working with the power systems since the early 2000. So, like Torbjörn, I'm also an IBM champion for the last 2 years now, and have been doing quite many different kinds of stuff with the power systems during the last 20 years, but this Oracle, this is really intriguing topic. So that is the reason why I'm here today to talk about a little bit of our experiences on migration of Oracle systems from other platforms on top of Power, and the results and benefits that we have gained to our customers by doing that.
You did some really interesting projects lately, so I hope we can hear some cool stuff from you. So let's go a little bit in the agenda. We just have the areas more or less. When it's not really set, we have a lot of slides, and we will start with the slides, but mostly to have something to discuss around, right? So I will interrupt, and we can interrupt each other, and we encourage people in the call as well to ask questions or just not interrupt for fun perhaps, but play along and be with us. So we will talk about the Power service. Everybody knows what this is all about, if you're not familiar already. And we'll talk about IBM and Oracle, the relations and resources that you've been just said something about, right, already, François, but also what Tietoevry did, for example. And we will give and take a little bit from this as well. So I will start short about the Power servers. Okay, this slide should be later perhaps, but this is a Power server, comes from IBM, and it runs 3 different operating systems. AIX, which is Unix, the IBM version of Unix, and we have IBM I, which is unique operating system that comes from the AS400 system I. I-series was named before. This is an operating system that I know very well, which has the database integrated into the operating system as a number of cool, unique features and functions. And then you can run Linux as well. And we said it's a good idea this topic will be around Oracle, but of course you can run other databases as well. So this is just a DB2, of course. You can run DB2 on AX, you can run it on Linux, MongoDB, Enterprise DB, which is also good to mention, right? Because we have seen actually people moving from Oracle to EDB, but that's not the topic of today. The topic is to keep your Oracle stuff and just run it on Power instead of x86. And also SAP HANA works very, very well. Okay, so what is Power? This is not x86 architecture. There are 2 different architectures. When we're really down to the chip itself, the CPU. x86, which is Intel and AMD, are the main producers of x86, which is the PC server architecture, right? So they have this on laptops and PC server that runs Windows. Windows was at least 100% x86. Well, in the past, they did. Intel tried to do RISC-based versions as well, and Microsoft Windows ran on that. Anyhow, and now they're also moving to ARM, which is also RISC, one kind of RISC CPU. But anyhow, that's the other side. That's the standard server, if you say. And from my point of view, it's built based for PCs more or less, and I would touch on that later. Power architecture, it's reduced instruction set computers. So that's another way of doing, which is for many reasons why it's so efficient. And this is really built for massive data business applications. So if you don't hear much about Power servers, maybe you think it's not that common, but it is. So it runs everywhere in the world, of course, but also in different industries. You can see maybe small numbers, but to the top right, you have the list of different industries. So manufacturing, banking, distribution, everywhere. And you can see that the largest supercomputers in the world, all 3 runs RISC, I think. Number 2, number 3 are actually Power-based servers. we should not go into the details, but the number one is not the standard server like IBM servers that you can buy from scratch. I would compare the x86 like a motorcycle, right? It's very good for taking one person from A to B. Like a PC, it's good for a computer when there's one person doing things, but not very efficient. Of course, you can do things like you can have this, I don't know, remember the motorcycle it's called, when you have another one running with you, right? Or you can buy thousands of motorcycles, but that's not very clever every time, especially if you like a DHL, for example. It's better to buy something that is built from beginning for the purpose. So this is power servers, right? It's built from with a mindset of business application servers and data. And also one other important differentiation, I would say, we talk about scale up and scale out. Okay, so the x86 is always scale out, which means you reach the maximum capacity of your server, you buy another server, install operating system, you load your data, and do continue like that, which creates a lot of issues, right? So complexity, and the architecture is very, very complicated. And a lot of things that we see in the cloud environments and so on, they're solving issues that we don't have on the power box, because you have the scale up capacity possibility. Of course, you can scale out on power as well, but you can, in this case, we're talking about scale up, you can scale up to 240 cores in Power 10, I think, and thousands of threads. And actually, you can do it with one operating system, taking care of all the owning all the resources. Not that often that happens, but again, you can scale up if you want to. That was my short introduction. Now I will hand over to you, François, and I will mainly keep an eye on the chat and see if someone has any questions. And you can just tell me to move on the slides.
Okay, thank you, Torbjörn. So as you said, I mean, there is a big difference between these x86 and power technology. And the main reason for that is that power is a complete design, is a fully integrated. It means that when we design this technology, we do not design just a processor, a core. We just do not design a virtualization software or any other component. We design it all together. I mean, the teams, the development teams are working jointly. So one team on the core architecture and the processor architecture, and another team, but I mean, of course, jointly design the server. Which means that it's, I mean, when talking about performance, it's not just the CPU, it's also the capability the server has to deliver throughput, to access the memory, and so on. Of course, very important, we also designed the virtualization layer. That is a bare metal hypervisor embedded in the microcode. And this makes a lot of difference compared to x86, where you need to install a software for this virtualization mapping physical adapters to virtual adapters. We also designed the operating system. In this case, when it's about running Oracle software, it is AIX operating system. That we will talk a bit more details about Linux if you want later. But this operating system is built together with the server, with the processor, with the memory crossbar, with the I/O capabilities, and so on. Also, all the software components, I would say software infrastructure for cloud capabilities, for system management, for RAS, for security, everything is built together. So, and we'll see the details a bit later. That's also the reason why we have unique features in IT industry. We have features because of this combination and this complete design altogether. We have features. I just mentioned two of them here. That is called PEP. It's Power Enterprise Pool. There is also live update kernel that allows you to patch or to upgrade the operating system without stopping the Oracle database, and many more. So at the end, it provides a lot of benefits in terms of a solution, of security, availability, and so on. We'll see a few details a bit later. And also it is a long-term investment, not just because of the technology, but also because IBM maintains the roadmap and the support for the hardware, for the operating system, for all these components for a long time, which means that it helps customers to not go in many hardware refresh, migrations, complexity, and sometimes when you refresh, for example, I've been talking about Exata. When you refresh Exata from some generation to the next one, there is non-compatibility, so it results in a very complex operations, migration, and so on. So that's why we have this difference when comparing Power System and x86 for these Oracle database. Not only Oracle database, we're talking about open source databases and many other applications, but that's clear that it is a lot of difference. And finally, this infrastructure is not the most expensive part of the entire solution, of the IT solution. The infrastructure is depending on the implementation, but could be, I would say, something like 25% of the IT spending. The most important cost is on the software maintenance, and especially when talking about Oracle, many customers are facing this financial difficult situation where they are paying a lot of money for these Oracle licenses, for these Oracle software maintenance. So at the end, finally, a low investment, a not expensive investment in this infrastructure in the basement of the entire solution, of the entire stack, will help a lot to not only, of course, take benefit of these technology features, but also to reduce the cost of the solution. So on the next slide, I just want to highlight about this cost and the TCO. It is, I heard many times people saying, okay, by the way, the licensing core factor for the Oracle database and some other Oracle software, such as WebLogic and others, is equal 1 on Power, which means that 1 core equal 1 license. While on x86, it is 0.5, which means that for 2 cores, I need 1 license. So many people thought that the licensing cost, the software maintenance cost, is double on Power. And they're just looking to the first part of the entire equation when it comes to cost calculations. It is not just about the core factor and the licensing. It is also about the performance per core. It is about the CPU utilization rate. It is about the platform efficiency. And this entire calculation made the real cost calculation, I would say. So this is a kind of summary slide, and it's based on facts. It's not fiction. I heard other vendors talking that their infrastructure solution is 10 times better, 100 times faster, blah, blah, blah. This is based on non-IBM proof points, and we'll go through some of them in the next slides. But think about that. You need to understand the entire calculation. As a quick example, if you buy a server, whatever it is, and you use it 30% of the CPU, it means that you pay a lot of licenses, software licenses, which is the most important part of the cost, for a low usage at the end. The same server used at 60%, twice better CPU utilization, will be much more efficient in terms of TCO. So that's a quick example of these different parts of the total equation. So on the next slide, please. This is the first fact or proof point. It is not IBM, it is public. So if you go to IDC, you have the link at the bottom left. You will find a performance metric that IDC published. It's called QPI, Qualified Performance Indicator. It is for any kind of hardware, any kind of server. And you can, of course, pull the numbers from there and have these performance per core numbers. So when you look at the Intel performance per core, you see from 2012 to 2021 last year that there is improvement all along this time, about 60%. It's not continuous. Some technologies, for example, 2015, 16, was worse. I mean, less performance than the previous one. But in average, let's say that it is 60% improvement over this time frame. On power, for the same time frame, you see that it's 146 performance per core improvement across Power 7, Power 8, Power 9, and last year Power 10 technology. So from there are two messages here. The first is that this power technology, thanks to this unique design, I can't see the slide, Torbjörn, maybe something. But yes, I mean, this improvement is very high, and it's sustained, it's continuous improvement. The second message here is that when you compare the latest Ice Lake Intel processor, that is 10 nanometers, compared to the Power 10, which is 7 nanometers, it is 2.2 better performance on the Power 10 core compared to the latest Intel, which means that you remember the previous slide calculation, we have more than two times better performance for core. So you see that now, let's say that we are almost equal in terms of impact on the Oracle licenses, I mean, number of licenses. When you translate this in a customer situation on the next slide, it means that 60% over this time, it's equal to 5% growth per year. And you know that these databases are always growing, the workload is always more every year. So 60%, 5% per year. The 146% of power performance improvement for the same time frame is equal to 10% per year, which means that when you start buying licenses, Oracle licenses, for example, in 2012, because of the performance per core on power, you will be able to sustain up to 10% growth, database workload growth, without purchasing additional software licenses, additional Oracle database licenses. This is the real, I mean, the most important benefit, and I've been involved in in many customer benchmarks where the customer was running very huge databases, 200 cores database for these financial and organizations or banks where they have huge amount of data. And I remember one of these customers that was running on a Power 8 machine, this big database, and they had they had a very high growth across the years. So they want to estimate how many licenses they would have to buy for the future. So they came to this benchmark center here, and we run these the same workload on a Power 9 machine, and then they saved 46 of the 200 cores, and of course Oracle licenses. So it means that they free a lot of space for almost 2 years growth without additional purchase licenses purchased, just by refreshing these Power 8 with Power 9 infrastructure. So and I mean, this is the story. I mean, the story is that this technology helps in not increasing the spending in software. So on the next slide, and of course this is based on these IDC metrics. It's not IBM fiction. It is real fact and proof point. You have, so I will go quickly on this slide. I mean, it's also almost the same story, but it is another external proof point. If you go to this web link, that is in blue at the bottom right of the slide. It is about SAP. SAP published official sales and distribution benchmark, so their application that of course includes a database here, not necessarily Oracle database. Depending on the infrastructure vendor, they run these tests, but it is the same workload. It is an SAP test kit. So when you look at the numbers, it's almost the same. I mean, you find these more than 2 better performance per core on the P10 compared to the latest Ice Lake. It is on the previous slide, Torbjörn. And also you see these continuous improvement on power, while on x86 across these EV Bridge, Ashwell, Broadwell, Skylake, Skylake, and Ice Lake, it's not always the case. So, I mean, you can go to these web links and do the same kind of calculations. On the next slide, then it's public. This is not external, it's IBM, but it's public. It's a metric we use for these performance measurements on this power machine. It's called ERPerf, and but it shows all the same kind of numbers across the power generation. Of course, it's internal ERPerf. I mean, it's IBM ERPerf measurement. So there is no Intel test on that, but it shows that across this generation, customers will may save a lot of CPU, or will be able to run more workload without adding more cores. On the next,
François, sorry to interrupt, but this is related to the kind of world record or whatever they said, the subs per core, right? They did something in August.
Yes, you mean you're talking about the SAP on the previous slide. The SAP sales and distribution test is a public. I mean, it's a test kit that you can run for the SAP workload. You can run on I mean, the database you want, because it's at the application level that you do these workload. You run the workload, but it shows same kind of numbers. Does it answer your question?
Yeah, that's okay. You can go ahead.
Okay. So on the next slide, Torbjörn, then it is you remember the equation we were talking about performance per core. Now let's talk about CPU utilization. Again, there is a big difference between x86 virtualization and Power, which is called Power VM virtualization. And of course, it's because of the design. We have this virtualization embedded at the very low level of the machine in the microcode. It's bare metal hypervisor. So what's the result? Basically, on an x86 machine, you install VMware, Xen, or any other hypervisor. Oracle's now relies on, I mean, they were relying on OVM. They're almost stopping OVM and they now go to KVM. But it's an additional software layer that maps physical adapters to virtual adapters, and of course also for the CPU sharing. How this CPU works, you basically map a physical thread to a vCPU in a virtual machine. And the recommendation is to do this mapping one-to-one. I mean, which means that the VMs and the vCPUs are not mapped to the same physical thread of the core. Of course, 2 threads per core, HMT2, if you use these hyperthreading on Intel. Which means, what is the consequence? It means that if one VM at a certain time is not running the entire workload, it means that these vCPUs will not be loading the physical thread. And this is idle CPU. This idle CPU is not shared with another VM or another vCPU. I mean, this idle CPU is wasted, is not used, is lost. On the left part of the slide, you see that on Power, because of this low-level mechanism, there is a sharing mechanism. I will not go in deep technical details about that, but basically, a VM or an LPAR, whatever you call, that has a capacity entitlement, CPU warranty. For example, the LPAR has 2.4 capacity assigned. If it's using less, if it's using, for example, 1.5 or even less, this idle capacity will be given back by the VM to the hypervisor, to the pool of CPU. And then another VM will be able, because it needs to run a peak of workload, the other VM will ask the pool, I mean, it's an interrupt mechanism. This other VM will send an interrupt to the hypervisor saying, hey, I have, for example, 3.6 CPU assigned, cores assigned, but I need a bit more because I'm running a peak of workload. And of course, if there is idle CPU in the pool, it will be given to these other VM. So there is a real sharing mechanism at a real time, and this idle CPU will be reused, will not be wasted, which means that in a consolidation scenario, and these servers are not just running one VM in general, they are running several VMs or tens of VMs. It means that the CPU utilization of the server will be much higher on this Power machine compared to Intel boxes. That's a big difference. This is the second part of the equation, you remember. And last thing about that is that this virtualization is recognized by Oracle as what they call hard partitioning, which means that you pay for the cores that you use. You do not pay for the entire machine, such as on VMware. You know, if you run Oracle database in one VM, Oracle says you need to pay for all the cores of the physical server. That's not the case on Power virtualization. You pay for the LPAR, the VM, or you pay for what we call a shepherd's pool, and you will size this pool to the number of cores that are required for all the VMs that are running Oracle database. So there is a kind of, I mean, instead of adding, adding all the peaks and sizing for all the peaks, you will size for the peak of the entire Oracle database footprint. That makes a lot of difference in terms of licensing. So now you remember we were almost balanced with the performance per core. Now we have a better picture from the number of cores and of course number of licenses. That's one point. On the next slide, please, Torbjörn. This is a quick example. I will not go in too many details, but you have this example of 3 VMs running Oracle database. They have capacity, CPU capacity assigned 5.1, 1.9 for the one in the middle, 3 cores for the one at the right. And these 3 VMs will run their CPU from this pool that we define. Could be, I mean, you can define these dynamically. You can change the values dynamically. You don't need to stop the server. You don't need to stop the database and so on. So we size the pool for 10 cores. That is the, I mean, the equivalent to all the capacity entitlement that has been assigned to these VMs. But at the end, we will not need to assign more cores. So thanks to this sharing mechanism, and you will pay 10 licenses, no more than that. At the bottom, there is a short comment about live partitionability. I mean, we invent technology. I mean, IBM is a technology company, and we invented this live partitionability that was very useful for customers, of course, for planned maintenance. They didn't need to stop all the VMs in a server when they had to do this maintenance. And all the customers were using that. It was very, very easy operation. And by the way, a few years later, Oracle said, okay, if you use this technology, you're going to pay more licenses and so on. So you see, it's very different strategy. We do technology, they try to use technology to capture more revenue. So, I mean, the technology is something that should help customers, not the contrary. So on the next slide, this is also unique. So if you're running several physical servers, you have this, it was called Power Enterprise Pool. Now it's called Power Private Cloud with dynamic capacity. It means that instead of activating or buying cores on each of the server, because for example, in the use case is disaster recovery, the disaster recovery server is not using all the cores. So why you would have these cores there active, and why you would pay for these cores that are most of the time doing nothing? So instead of that, in this technology, we have this unique feature that is, I mean, where you define the base capacity activation across all the physical servers. So, I mean, you can't find any other technology that has this mechanism. And then there is what we call a cloud console. It's monitoring the CPU utilization in all the servers, and it will, I mean, it will use the cores on any other server up to this base activation. You can also define a kind of per minute additional CPU if you need. But by the way, that's, I mean, even if in a simple scenario where you have a production server and another disaster recovery server, you can say, okay, I'm going to buy just the base activation. So when I do the failover from the production to the R, I don't need to buy all these cores that are doing nothing most of the time. So this is a very helpful also feature for these customers that are, I mean, we were talking about disaster recovery, but it applies to many other use cases also. So on the next slide, again, this is a proof point. It is not from IBM. It is ITIC, this organization that has collects a lot of information and make a lot of reports about availability, about RAS, about resilience, and the picture is very clear. You see, we are number one with a very low unavailability. So it's both for planned and unplanned downtime. I mean, you have several reports in these ITIC. You have the link at the bottom left. When you look at these machines, I mean, for example, x86 from Sun or Oracle, it is, of course, not the same level of availability. So, and very important point also, this is from 2020 report, but it's 12 years in a row that we're number one. And again, this is of course because of this unique design where the RAS, the availability, is embedded at the first beginning of the design in all the components of the infrastructure. So what could be the impact from the Oracle software point of view? Oracle claims that customers should use these rack option, building the database as a cluster across several nodes. Why not? It's fine. We have many customers that are using this feature on Power Systems. But if the business, your business, or not all database might be critical, why paying for this very expensive database option that is $23 US per license? This is list price acquisition plus, of course, the 22% software maintenance. While your database will, I mean, your KPI and your business will get enough RAS and availability by running on Power. So it has, I mean, this availability has impact on the cost, but of course, on the way the technical people will be living. I mean, from when you have a crash or a downtime, or even if it's a planned downtime, it's a lot of people that you need to ask to come at night and do the maintenance on. So you see that it is cost impact, but also it is operations impact. On the next slide, this is about security. Also, the picture is very clear. It's from another organization. It's called NVD. These guys are also producing a lot of reports about security issues, vulnerabilities. And I put two topics here. I mean, at the top right, you have the virtualization, comparing, for example, Power VM to KVM. You see the number of records that is very different. And at the bottom left, you have a comparison for the operating system. AIX is a very low number of vulnerabilities. There is Linux. I don't know which Linux, if it's a special distro, but you see that the number of vulnerabilities are much higher and also increasing. So again, this is impact on the risk. You know, the risk of having, and especially today, we have all these stories about ransomware. So it is also a huge impact. And you may not need to install complex security features on these machines. I could go in many more details about these vulnerabilities, such as, you remember Spectrum meltdown we had 2 years or 3 years ago. These machines are protected against these kind of threats. On the next slide, I just quickly want to say that we keep improving the security on the latest power system generation technology. This Power machine, we have improved this security. And as a quick example, the entire memory of the server, the physical memory, is encrypted at the hardware level. It means that in each of the cores of the Power 10 cores, we have 4 crypto engines, so much higher number than in previous Power technology, to have this hardware acceleration for the security, but not only security, of course, also encryption is addressed by these crypto engines. So again, this may have impact on the cost. Oracle has an option of the database that is called TDE, Transparent Data Encryption, that is not for free, and it's also a lot of complexity. For example, a DBA will have to say, okay, I'm going to encrypt this table or this partition or this part of the database structure, while here with this technology, you encrypt everything. I mean, without management complexity, and not only, of course, the database, but the application and so on. On the next slide, I'd just like to explain that we have these Power machines that are running on-prem. They can be running on-prem. They can be running as a private cloud with these features. You remember these enterprise pool capabilities. This is related to cloud. We also announced, but maybe we will talk a bit later about a new offering that is called Power Private Cloud Rack for Oracle Database. And also we have a Power Virtual Server that is co-located in IBM Cloud. So it's very easy. You go to this website on IBM PVS or Power Virtual Server, and you can quickly deploy, I mean, an LPOR or several partitions and get access remotely to these. So you can use these PVS co-located with IBM Cloud for many different reasons, just to offload or to provide a test for development environment. And of course, whatever you're running these machines, these technology, you have these automation, you have deployment capabilities with Red Hat Ansible. In the Ansible Galaxy, we have scripts for automated deployment. This Ansible relies on these components that we embedded in the technology. For example, Power VC, that is the OpenStack underlying layer for this automation, just below the Ansible automation. So it's no looking, it's open and it's optimized for these Oracle database, Oracle software, but also any kind of capability, including the cloud. I see that there is a question. Yes, a good question about AWS Azure. The AWS Azure relies on clouds relies on x86 technology, and I told you that the core factor for these Oracle licenses is .5. It was because Oracle is very aggressive against other vendors, and especially AWS Azure. So Oracle just changed the rule like that in a snap a few years ago and said, okay, if you run Oracle database in these AWS Azure cloud, you're gonna now pay one license for one core, which is equivalent, of course, as on Power. But of course, you don't have the same performance per core. So that's, I hope that it answers the question about that, which means that Power Virtual Server is a very good performance cost ratio, because you have the same licensing as on AWS Azure, while getting much better performance per core. On the next slide, Torbjörn, this is, I would say it's not new, but it's something most of the people do not know. We have, of course, these Red Hat acquisition, I mean, 2 years ago, or I can't remember exactly, it doesn't matter. But the idea is that with these Red Hat and OpenShift technology, we have customers that now are able to build new kind of applications, new applications with microservices, with containers, while running the backend database on the same physical server, on the same machine. And of course, it's a lot of innovation. It helps these customers to transform their legacy application in modern application. And of course, the database is running in an LPOR or in a VM, whatever you call that. most of the time the database is not containerized because there is no reason to have a container for this database. It's not something that is changing often. And also for this critical database, you need to rely on resources, CPU, memory, and so on. So that's why the database, the backend database, stay in a virtual machine, in an airport, and then you collocate this new modern application based on Red Hat, OpenShift, and containers and microservices. And of course, you can build this new application whatever in the cloud. We were talking about Power Virtual Server, and then bring it back when you want to run in production on a private cloud on-prem, or I mean, it's very flexible. You can collocate everywhere from private cloud to public cloud. So I can remember if there
I think this was your final slide, actually.
Okay.
François.
Okay.
So it was good. Thank you very much. It was a lot of information. And I mean, for me, this is almost shocking, especially when you see customer not using this, not running. Why? I mean, they should be doing this. And this is why we have Tommi in the call, because you did this, right? You've seen those presentations many years ago, Tommi, and what is your experience around this?
Yeah, can you hear me, by the way? Because
yes,
I told about this snowstorm, so it seems to be slowing my lines a little bit. But yeah, yeah, very good stuff, François. And I can really say that all this stuff that has been mentioned here today is working in real production and with the customers. At least we did last year with our product manager Stanislav Haberland, like awareness sessions inside the Tietoevry company, because like Björn said, it's quite often the case that people don't know about the Power architecture that much as from the x86 side. So we held these awareness sessions and we told about our Power platform and the, let's say, private cloud solutions that we have been building inside Tietoevry, and we call it Cloud on Power. So that is like automated platform that we have been building on top of Power systems, and it has integrations to our ITSM tools like ServiceNow and IP management stuff and this kind of issues, so that the customer can go to service channel and just click on catalog item and order on LPAR, AIX or Linux on Power LPAR from there. And like said, on these awareness sessions, we had our consultants and technical architects from the customer units. And as a result of those awareness sessions, we got quite many contacts, and we noticed like a pattern from there that it was almost the same case on all those issues, so that they had customers who were running Oracle on physical x86 hardware, and either the hardware was oldening or the operating system was running out of support, or both, or the Oracle system was on very old level. So we started checking those cases through, and quite many of those, the customer chose to renew the environment on top of Power and virtualized on top of Power instead of that physical x86. So they bought that like as a service, the IaaS layer as a service from us. And
do they, sorry to interrupt, Tommi, but do they see any difference? Will the customer, or is it similar from the customer point of view?
Well, Tietoevry or our company, we like a full service house, so they can get all those services. They can get the IaaS layer and they can get the database management from our company as well. So we are doing like a lot of cooperations with the database team in Finland and Czech and throughout our company. So it's basically it's like a single point of contact, so that they can easily get all the services that they need to run the services. So you were talking about the difference. So yeah, I think those customers, they had like quite a lot of pain of maintaining the hardware and those support and that kind of stuff for the hardware. So instead of all that headache, they get just the service. So they don't need to care about the lifecycle management of the hardware, and they got more flexibility because they have these catalog items that I mentioned. So if they need to increase the, for example, memory on their Oracle system, they can go to the service channel and then click on the catalog item, and yeah, let's put like 24 gigs more memory to my Oracle system, and that's it. So it gave them
so that's
a lot
much more flexibility.
Exactly. Yeah.
Okay, so that's one part. The other part is the application itself, and that I guess looks the same, right, for the end users. They don't see.
Yeah, that shouldn't be. If you are having like an application layer that is using Oracle as a database, it should be totally transparent. If it's like Oracle or Power or x86, so you don't need to do any application changes, even though the database platform changes. This said, I need to say that there are some exceptions. So we had many success stories. So I think we had like 6 or 7 of these cases. So most of them went fine, but in the name of honesty, I need to say that we encountered problems with one case, and that was, it was a customer that had 4 databases, Oracle databases running on x86. So we throw 3 of those nicely on top of Power, but then there was one database that has been like, that had been fine-tuned like 10 years just to match with the x86 architecture. So that struggled, and that we needed to draw back to x86, but that was a lesson learned, and we now later on know that you need to be extremely careful with the, let's say, prereqs, or do some background study on those issues. So
yeah,
but most of the cases, yeah.
Good message to the customers to not optimize too much, right? To be able to move to other platforms.
Yeah, you should be like platform independent and keep your databases on the standard level. So this particular case, so it was so heavily fine-tuned towards that platform. So it was like an exception, I would say.
But by the way, I related to this point, I would like to add that we have a migration assessment workshop offering, where we and of course we can collaborate with you, Tommi, on that. We are able to analyze in advance the database workload based on monitoring output files such as Oracle AWR files. And then based on, we have a tool that is called Exerciser, for example, but we have other tools. And this tool will analyze all the metrics from this database monitoring, and will provide, they provide a report where we understand if there is a special customization at the database level, and especially in these Exadatas, there is this storage software in the storage node, so we understand how these storage software, what they call the secret sauce, how it's used, and most of the time it's not used. So then the migration goes very easily. But on sometimes, then if these secret source, similar to what you mentioned about these x86 migration case, so these tools will help us to understand in advance if we need to take special care about the migration, or if it's a typical migration with transportable table space techniques, or data guard, or any other.
So,
Yeah.
Francois, back to you, because there was mention in your presentation regarding Linux and Oracle, because the support is AIX, right? Oracle and Power should run on AIX.
Yes.
But what about, you mentioned, but can you touch it on it again, the Linux?
Yeah. I mean, Oracle software database, WebLogic, Oracle application, CBEL, eBusiness Suite, any other runs on Power on AX operating system. We have a client, a Linux client, that you can use to develop or run application tiers on the same physical server running on a Linux LPOR, while connecting to the database running on AX. So you can collocate both. What about AX? We have about 80,000 customers worldwide that rely on this power system technology and AX operating system to run their Oracle software. 80,000. It's a huge number. So that's the reason why we have a collaboration, even if there is competition on some areas with Oracle. We have a lot of collaboration to maintain and to have a strong roadmap for the future for these customers. Whatever we're talking about the Oracle database on the long-term versions, currently the 19C, also on the AX, now we have AX.3 that has been announced recently. 7.2 is long-term support also, and of course, power technology. So, I mean, it's a strong and a long roadmap for both companies. There is a statement that was published by Oracle a few months ago about this long-term joint engagement. So yeah, I mean, it's not Linux. It's not based on Linux. There is this client on the Linux side, but on the AX side, it's a strong and long-term roadmap with this huge number of customers. Yeah.
Good. So we're actually on the top of the hour, but I have a few questions still. I think we can continue, and I guess people will drop off if they have some other meetings, because there was another announcement early on this week, I think, the private cloud rack for Oracle.
Yes. So we build a new offering that is a ready-to-use infrastructure as a private cloud to run the Oracle database. I need at least to replace Exadata. Why? Because there are many Exadata customers that are looking for alternative solutions for any reason, because of the cost, because of the complexity, because as I said, most of them are paying for this storage software, these secret sauce that is running in the storage node, but it's not leveraged. I mean, it's not used by the workload. Most of these ISV applications are not taking benefit of that. So, and also because their Exadata is reaching end of support, or because they reach the maximum storage capacity, so they have no more storage, and instead of extending the storage on Exadata, they may look to other infrastructure solutions. So we build these ready-to-use solution. It's a rack where you have power server. You have several configuration. There is eighth rack, quarter rack, half rack, and full rack. You have a lot of flexibility. You can have a single server, or you can have a dual server. Then you can keep running Oracle rack if you want. We have storage in these chassis, a flash system storage with by default, the usable capacity an Exadata has, but of course, it is very flexible, and you can activate additional cores, or you can use additional cores, additional memory for future growth if you want. And of course, it's pre-wired with SAN switches, with network switches, and also automation capabilities. I was talking about Power VC for these easy deployment. So the idea is to help customers that are looking for alternative solution instead of refreshing Exadata, to have these solution and be able to deploy a database in a few hours instead of weeks or days. These chassis, you plug, it's plug and play, I would say. Of course, the Oracle database code is not installed, but it can be easily deployed with this Power VC or Ansible. In the Ansible Galaxy, there are a set of scripts or packages where you can download and use to deploy a single instance database or rack database. So the provisioning, everything is automated. And
Tommi, would this be of interest for you guys, or do you have your own infrastructure already? What do you think about this?
Basically, when it comes to Tietoevry, we have let's say our infra. So we have ready-made private cloud solution, like stated. So it's based on Power hardware, and it has the integration. So, but I would say that maybe nothing would prevent us to check that whether that if it's like Power hardware, you should be able to just to plug in that as a part of your existing infrastructure and utilize as such. So definitely that sounds like an interesting setup, knowing that we have the growing amount of Oracle customers on Power.
Yeah, at the first beginning, we thought about these Exadata customers that might be looking for something else. So that was the reason for building this offering. And also, of course, the list price is cheaper than an Exadata refresh. I mean, I'm talking about the hardware list price. Then, of course, on top of that, there is a software cost savings. But then this is another story, as we said.
It's very interesting message. I mean, this is something IBM invest a lot in, right? So it's a good message to the market as well. This is coming out from IBM. So anything else you want to discuss? Now people are dropping off quite rapidly, so that's okay, of course. We went over time.
Time is up, I think. Yeah.
Time is up.
Anyway, if you have any question by mail, feel free to ask, and we will answer this question and help these customers.
Yeah,
that's
definitely
good. Very good. Thank you very much both for joining, and maybe we can follow up later on this year with another webinar around this topic, because it's an interesting topic for sure.
Yeah.
Okay.
That sounds like a good plan.
Thank you very much, and talk to you soon.
Thanks a lot. Thanks to you, and have a good day or afternoon.
Same to you. Bye-bye.
Bye-bye.
Bye, guys. Everyone.